Okay, so we're still talking about systems of linear equations, which basically means two equations that up to this point, we have solved by either graphing or looking at a table, although that's kind of a little rugged. The table, you actually have to pick the right numbers to put into the table in order to get some positive results there. So I talked about a couple of things today. One was substitution, and I'll show you how to do one of those. And then the other, I put canceling, but I use a more technical term. It was elimination is what the last thing I covered in class today. So we're going to look an example. I did, this is number one off of the sheet here. Just expand my pen a little bit. So here's number one off the sheet, off the homework for you. You got y equals x plus 1 and 2x plus y equals 7. Now look at this equation and I say, okay, wait a minute. They've already got me set up to do something here. They've got the letter y equal to all of this right here. So here's the idea behind substitution. If I have y here that's equal to all of this, then I could take all of this, substitute it in down here for y. And here's what that's going to look like. So I'd have 2x plus whatever y is, but now I can substitute in x plus 1. So I can go x plus 1 equals 7. Now I have an equation with one variable and one variable alone, and I can solve this equation. Anytime you have one equation, one variable, you can definitely solve it. So I have 2x plus x is 3x plus 1 equals 7. Subtract 1, 3x equals 6, divide by 3, x equals 2. Now obviously I've got x equals 2, I've got one of the solutions. I still need y up here. So I can use either one of these equations, either this equation or this equation. And I can put this, the 2, back into the equation. I'm going to use this one right here. So this is going to become 2 times 2, I'm substituting 2 in for x, plus y equals 7. 2 times 2 is 4, plus y equals 7. Subtract 4, y equals 7 minus 4 is 3. There's my solution to the equation. Again, I will repeat, if I looked at the original equations, I could graph those two equations. Those two lines would cross exactly at this point. Let's do another one. Let's look at something I got to work with a little bit. Let's look at something like number 8, let's say. 8 shows, what do we got? 3x plus 2y equals 9, and then x plus y equals 3. Neither one of these are set or good to go. I don't have a variable all by itself, but I can easily look at this one right here and say, okay, well, if I just subtract x from both sides, I'm going to get minus x, right? I'm going to get y equals negative x plus 3. So now I got y all by itself, and I can now substitute in negative x plus 3 every time I see y up in this equation. So let's rewrite. So now I got 3x plus 2 times whatever y would be, but now I'm going to substitute this in, negative x plus 3. Sorry about my penmanship, equals 9. I am going to distribute the 2 over. So now let's see what this looks like. 3x minus 2x. That's going to be what? Plus 6 equals 9. 3x minus 2x is x. So I get x plus 6 equals 9. X equals 3. Because if I subtract 6 from both sides, I get x equals 3. Now I can take this, plug this up into this equation. So I have y equals negative 3 plus 3, which all ends out being 0. So there's my point, 0, 3. And that's how we solve equations by substitution.